And time reversal. This is again very, very important. Or this time reversal is otherwise called time folding operation. So it is reversed with respect to the y-axis. You can imagine like this. So if I am folding my signal, right, then whatever I have at the right hand side will coming into the left hand side, and at the same time whatever I had in my left hand side will be coming to the right hand side. That is the time folded version or time reversed signal. So in the time reversed signal, it is written as y of t is equal to x of minus t, whereas my x of t is my original signal. Or if I am representing in the discrete domain, and x of n is my original signal, and x of minus n is the folded signal. Look at here. So this is a better understanding. We can able to have a very clear idea about the time reversal concept here. So this is with the continuous domain. So here we are having this signal, this signal we are having in the left side, and this signal on the right side. This is my original signal. In the folded version, we will have this. So you imagine you are going to place a mirror on your y-axis, right? So whatever you are having on the right hand side will be available in the left hand side, and whatever you are having on the left hand side will be available on the right hand side. So this is the time reversal concept. And other things are very simple. And here the scalar multiplication, the signal is multiplied. That is, here the signal amplitude is scaled up or scaled down process, right? So x of n is my original signal. Then in the scalar multiplication, I can have y of n is equal to 2 into x of n, or 0.5 into x of n. So the scalar value is here. Suppose if I am representing it with alpha or with the lambda, so y of n is equal to lambda into x of n. So this is the scalar multiplication. Whereas if I am doing with the time scaling, that is with the g of within the bracket, along with your n parameter, you will have your lambda value. That this is the major difference between the scaling in the amplitude side as well as in the time side. And signal multiplication, if I am having my signal, for example, x1 of n and x2 of n, then output signal is y of n, then y of n is equal to x1 of n into x2 of n. And also for signal addition, x1 and x2 are my input signals, and y of n is my output signal. In that case, y of n is equal to x1 of n plus x2 of n. And here in these two concepts, we should be very careful while doing our operations. The signal should be multiplied or added with the corresponding positions, right? That is very, very important. Even if you are doing the subtraction, the signal should be done at the corresponding positions only. That is the meaning here is, if I am doing my x1 of n plus x2 of n, then x1 of 0 will get added with x2 of 0. Then we will get the answer as y of 0. And similarly, y1 of 0 will be obtained by adding the signals at x1 of 1 plus x2 of 1. That is the corresponding positions. N value should be same for the signals, input signals. So that is very, very important.